Today's a big day where we finally learn officially the Pythagorean Theorem and the distance formula. But both of those formulas are things that you have learned many times before. I bet as soon as I start to write this, you'll know how to finish this. A squared plus b squared equals, you are right, c squared, right? This is the famous Pythagorean theorem where a and b are the legs of a right triangle, and then the c is always the hypotenuse, always the longest side across from the right angle. Or another way we can say the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. So when we're setting up an equation, we always want to make sure that we're equaling it to the hypotenuse. So sometimes before I start, I might even just kind of go and do a little scribbling of the hypotenuse of each triangle. Then I can write a squared plus 24 squared equals 26 squared. Now it doesn't matter with the legs which one you say first. So you could say a squared plus 24 squared, or you could say 24 squared plus a squared, right? Either way, that's like the same thing. So then we gotta go to our calculators and say, well, what's 24 squared? 24 squared is 576. 26 squared is actually 676. If I subtract from both sides, I get 100. And then you'll remember that you take the square root at the end for the final answer here, which is 10. So a equals 10. Similarly here, we have 10 squared plus 24 squared equals c squared. This is actually the same triangle, just solving for the hypotenuse instead of solving for the side. So again, when we get to the final step, we take the square root of both sides, and 26 is equal to c. So 10, 24, 26 is what we call a Pythagorean triple, right? It always works. Here with this one, that doesn't always have to be a Pythagorean triple, right? It doesn't always have to come out perfectly even. B squared plus 15 squared is equal to 20 squared. When I subtract 225 from both sides, I get 175. That is not a perfect square, so I would go to my calculator and type in square root 175. It's going to be a decimal, and I'm going to round that to 2 places after the decimal point, or what we call the nearest hundredth, 13.28. So if it doesn't come out even, we can just do the square root on our calculator. These questions are similar where they say, okay, is this the sides of a right triangle or not? And we would just test it. Does 2 squared plus 3 squared equal 4 squared? It's like is 4 plus 9 equal to 16? No. So it either works or it doesn't work, right? Here again, we have the 26. I'm putting that last, right? We've got to always make sure that the biggest side is last. And again, this is the one we've just done a couple times. So we know that, yes, that does work. For some reason, I'm not showing number 6, but I know that number 6 exists on your paper. And so that one is find the length of the shortest route from your school to the library. Oh, it's right here, right? So here's the problem here with C. So this is going to be 1 squared plus 0.5 squared equals C squared. And again, this one's not going to come out even. This is plus 2.25, so 3.25. Well, we can just take the square root of both sides. So C is going to equal about 1.80. Pythagorean theorem. Then we're going to use Pythagorean theorem to actually show what the distance formula is. So distance formula finds the distance between 2 points, right? So between 2 points, how long is the distance? So what we're going to do is we're going to take this and create a right triangle where we're going to be looking for the hypotenuse. And when we create our right triangle, we can count the legs. Like this is a 5, and 1, 2, 3, 4, 5. This is a 5. So then we can use Pythagorean theorem, 5 squared plus 5 squared equals c squared. The nice thing about these problems is that you're always looking for the c squared. 50 is equal to c squared. And again, that doesn't come out even, so I can type that in 7.07 for c. So I've got to create the right triangle, and it doesn't really matter which way you can create it. Like I can create it this way, or I can create it that way, and it's going to be the same answer either way. I'm going to do this one this way and count my legs. 1, 2, 3, 4 is this leg. 1, 2, 3, 4, 5, 6, 7, 8 is this leg. And again, I'm always looking for that distance or hypotenuse of c. So a squared plus b squared equals c squared. Again, it doesn't matter what order you add the 16 and the 64. Either way, it's going to be 80. Square root of 80 does not come out even, so I would type that in my calculator. Square root 80. Round it to 2 places after the decimal, 8.94. Last one. Here's again my hypotenuse c that I want to find. I can carefully draw a right triangle, count the sides. This is 4. 1, 2, 3, 4, 5. So it's going to be 4 squared plus 5 squared equals c squared. Right? So if I add that up, it's going to be 41 equals c squared, right? Then I would take the square root of 41, type that in my calculator, and get 6.40. So distance formula, basically from using the famous Pythagorean theorem, a squared plus b squared equals c squared.